example 6a, you have to add e to both sides. Whoops. And then that cancels out, so then you're left with x equals e to the 2/3. And then you plug that in your calculator and you get x is equal to 1.9477. And I don't know how to make that box thing.
Hey, thanks for the help, Mullet Makenzie. So that's how you solve for A. And Makenzie, the important thing is she knew how to solve the problem, just didn't know how to make this box thingy here, put around your answer. But that's okay, we'll let that one slide. Here for letter B, this one's not so bad either if you use one of your properties of equality from back in 3.3. Notice that your logs are the same base on both sides, so you cancel, and you end up getting just a 3x plus 2 on the left, and that's going to be equal to a 6 minus x on the right. And so if you add x to both sides, because that's what we're trying to solve for, add x, and then we're also going to go ahead and do this all in one step. Subtract 2 to both sides, so your 2's cancel, your x's cancel. You get a 3x plus an x gives you a 4x, and that is equal to 4. Divide by both sides by 4, and you get x equals 1. And here's that little box thingy we were talking about before. So you get that in there. And now the last one, which is usually a little bit more difficult, is letter C. If you notice, for B, you had a log on both sides which cancel. For letter C, you have 2 logs on the left and 1 log on the right. What you need to do is you need to combine the logs on the left into 1 log, and then you'll be able to cancel the logs on both sides. So if you have a subtraction sign, that just means you're going to get the log base 3 of, you use division. 5x plus 13 over 6 is equal to the log base 3 of 3x. And you have the same log on both sides, so here you can cancel those. And what you're left with is a 5x plus 13 all over 6 is equal to a 3x. And what we've done is we have basically set up a proportion. We got rid of our logarithms, and now we can just solve for x. So if we have this proportion, basically you can just multiply both sides by 6. That might just even make it easier than doing cross multiplying. Either way, your 6's cancel on the left, and you get a 5x plus 13 equals an 18x. Wow, this is so much easier than I originally thought it was. So then let's go ahead and subtract 5x to both sides. Minus 5x, minus 5x, and you get 13 equals 13x. So if you just divide each side by 13, x is equal to 1 again. Now whenever you get an answer when you're solving log functions, what you really need to do is you need to check to see if you get an extraneous solution. What you're checking for is you are checking to see if whatever is behind your logarithm, so here, here, or here, we know that 5x plus 13 has to be greater than 0. We also know that 3x has to be greater than 0. The 6 is already greater than 0, so that one's alright. But if we say x is equal to 1, if we plug a 1 back in here and we say that 5 times 1 plus 13, if that is greater than 0, then the solution will work for the first log, which it is. Second log we're good. And then if we take 3 times a 1 here for the third log, this has to be greater than 0. And we find out that 3 is greater than 0, we're good. So our answer, x equals 1, is correcto.